Okay, this activity you're going to be reading an article that's called Is There Really a Rock Cycle? And we're going to be doing an active read with paper today instead of doing it on the the account that you have through Amplify. So make sure you have this article. There is the title, Is There Really a Rock Cycle? And then you'll see that there are several small little diagrams on the front as well as some diagrams on the back. So the first thing I want to look at is just an example of a cycle. So we'll take a look here. And this shows a diagram here. And on the side here, it just mentions that if you look closely at the diagram, you can see the life cycle of a butterfly. Um, and you've probably learned a little bit about this before. There is this idea that things can only go in one direction. If you're a butterfly egg, you can only become a caterpillar. You can't go back to being a butterfly. So typically, when we talk about cycles, we're thinking something might just go in one direction and then complete itself and continue and go on. Yesterday, in our game that we were playing with the rock transformations, when you move from table to table, we saw that the same type of rock could go back in the cycle and become what it just came from. Rock that had cooled from magma could get reheated and turned back into magma, or a rock that was turned into a sedimentary rock because of a pile of sediment could itself be weathered and then returned into a sediment pile. And so we can see that the cycle for rocks continues to go in not just in one particular direction. The article that you're going to read today is called Is There Really a Rock Cycle? Sometimes we hear the this idea of a rock cycle, and we were just talking about cycles, and so we might start to wonder, is that also true in this case? So let's take a look at this article a little closer. So this is just the first page of it, and I'm going to go ahead and can I do this? Yeah, I can. Okay, so I'm going to go ahead and grab a pen, and I'm going to just look at this sentence that talks about igneous, sedimentary, and metamorphic rock. And I would like for you to pause the video if you need to, go get an article and underline these things along with me. I'd like to have a couple of annotations that are the same as you. So when we were looking at the models of different rocks that we've taken a look at before, we know that we have these three different types of rocks. However, it says here that they can change or transform from one type to another, and any type of rock can transform into another type. So I'd like you to underline that, and then off to the side, take a moment to write down a comment or an experience or something like that you have that shows that you understand that any type of rock can transform into another type of rock. If we take a look at this rock cycle diagram down here, and let's look on it a little bit smaller or bigger, I mean, you can see that this particular picture is not very scientific. It does use the words igneous and sedimentary rock, but it definitely gets the attention of a person who is looking at this. But rocks obviously don't really have arms and legs, so there's some things that are not very scientific. They don't have eyes. So I might write here, I might write a little note off to the side that mentions that I think this isn't maybe very scientific, but I might mention ways that I think it is accurate, like it shows the different types of rocks and how igneous rock could become sedimentary. It's missing out on explaining that igneous rock could turn back into igneous rock, or igneous rock could turn into metamorphic rock. So you might want to draw little arrows and something like that to show that you understand that. If we take a look at the next picture, this one here, this picture here is this diagram is one person's sort of claim about how rock changes, and you already have evidence that does not support this claim. So this idea that rocks can only be one thing and then turn into another thing. You need to be critical about these different diagrams when you look at them. Sometimes an artist is trying to show you something that they understand. There's a lot of things about this that are actually really good, and one thing that I like is that they show the metamorphic rock here with these sort of lines that show how much pressure this rock has been under And this is not something that you see in a sedimentary rock. And so you can see that they're showing you this rock, this particular rock being turned into a metamorphic rock. But in fact, you could have an igneous rock that can turn into a metamorphic rock. And when you look at that, it wouldn't have sedimentary lines that are folded, but it can actually have some different stripes and things, because sometimes the pressure itself can make some of the crystals in an igneous rock all line up together in one way. So you can take a look at that. The next picture, and this is in color, and on your diagram you won't be able to see it that way. One thing that I really like about this one is that it shows weathering and erosion happening at the surface, and that's one thing that might be worth making a note of. You might circle those and mention that in a note here that this happens at this is going to be too hard for me to write, but you could say at the surface. I'm just going to do ... You can fill that in. Just to kind of mention that that's really an important part of the whole cycle. Something else that you could say is just that it's showing the melting, and it's kind of cool to see that it's showing the igneous rock might be here, but it's a little bit bland, not bland, I mean vague, because this right here, this whole section here, it mentions that it's igneous rock, but it doesn't really leave for the opportunity that it could be not just in these stripes like this. It might be a bit messier than that. So it's for that way, as cool as it looks, it might not be as scientific as you need it to be to explain it. Okay, so kind of coming back to your overall active reading here, what I'm going to ask you to do is to read each paragraph. Find throughout the document a couple of places where you can write a question or a comment or something that really helps you understand what's going on. I want you to pay special close attention to everything that you see on the back page. These diagrams are really great in that they show that every type of rock can become magma, that magma can only cool into igneous rock, but every type of rock can become sediment, and sediment can then become sedimentary rock, and every single type of rock can become metamorphic. So make sure that you're reading these paragraphs here. It's going to go into more detail about that. All right, when you're finished with this, then we're going to move on to part 2. But before I have you start with this whole thing, I just want to remind you about the active reading guidelines. So remember to think carefully about what you read, pay attention to your own understanding, ask questions and make connections as you read, and remember, really, like, no question's too simple. But if you write a really simple question and you want to elaborate, that's good, but just asking questions is the most important part. And then in bold here, because for this particular article, it's important to really pay attention to diagrams, so I put this in blue so that you can just really focus on it. And then as you're doing this, or when you're finished annotating it, be sure to talk with your table partner about some things that you saw. And when you're finished with this, then you can go ahead and go on to the next part.